Hello everybody. In this video we are going to be looking at the solutions to the Physics 1 refraction practice problems. Let's start with problem number 1. It says for the drawing, find N2. So we want to find the index of refraction for our refractive medium. So we are given my index of refraction for the incident medium, and that is 1.5. We are given my angle of incidence, and that is 45 degrees. We are given the angle of refraction, and that is 65 degrees. Again, we are looking for my index of refraction for the refractive medium, or N2. We're going to use Snell's law to solve this problem. And when we take Snell's law and we want to solve for N2, I know that N2 is going to equal N1 sine theta 1 divided by sine theta 2. Plugging my known values into that equation will give me an index of refraction for my refractive medium of 1.2. Problem 2. For the drawings below, state whether N1 is bigger than N2, or if N2 is bigger than N1, or if N1 is equal to N2. All right, let's take a look at our first drawing. So on our first drawing, we can see that we have my incident ray coming in right here. So that is my incident ray. And then we have my refracted ray after it goes through the boundary going right there. I can tell that my angle of incidence, which is theta 1 right here, is kind of shallow, and my angle of refraction, theta 2, is going to be bigger. Remember, we always measure our angles from the normal, and the normal is this line that is perpendicular to the boundary between the two mediums. So because my refracted ray down here in blue is bending away from the normal, in other words, my angle of refraction, theta 2, is greater than my angle of incidence, theta 1, I know that it is going from a slower medium to a faster medium. And because it's going from a slower medium to a faster medium, my index of refraction for the slower medium has to be greater than my index of refraction for the faster medium. So N1 is going to be greater than N2. Let's take a look at our second diagram. In our second diagram, we can see that my refracted ray right here is bending toward the normal. In other words, that my angle of refraction, theta 2, is less than my angle of incidence, theta 1. So that means that I am going from a faster medium to a slower medium. And because I'm going from a faster medium to a slower medium, the index of refraction for my faster medium has to be less than my index of refraction for the slower medium. So I know N1 is going to be less than N2. And now for our third diagram, we can see in our third diagram that the angle that my ray is traveling on doesn't change. The angle of incidence, theta 1, is the same as my angle of refraction, theta 2. So because my angle doesn't change, that tells me that my index of refraction has to be the same for both mediums. So I know N1 has to equal N2. Problem 3. A ray of light traveling from air into crown glass strikes the surface at an angle of 30 degrees. What will be the angle of refraction? So we're going from air into crown glass. So I know the index of refraction for air is 1. The index of refraction, or N2, is going to be 1.52. My angle of incidence, theta 1, is 30 degrees. And I am looking for my angle of refraction, or theta 2. So using Snell's law to solve for theta 2, And solving for theta 2 will give me theta 2 equals the inverse sine of n1 times sine theta 1 divided by n2. I plug my known values into that equation, and that will give me an angle of refraction, or theta 2 will equal 19.2 degrees. Problem 4. A light traveling through air encounters a second medium which slows the light to 2.7 times 10 to the 8th meters per second. What is the index of the second medium? So I know that my speed of light in a vacuum is 3.0 times 10 to the 8th meters per second. The speed of the light wave, or the ray of light, in my second medium is 2.7 times 10 to the 8th meters per second, and we are looking for the index of refraction for our second medium. I know the index of refraction is the speed of light in a vacuum divided by the speed of light in the medium, so N equals C divided by V. 3.0 times 10 to the 8th meters per second divided by 2.7 times 10 to the 8th meters per second will give me an index of refraction for the second medium of 1.11. Problem 5. A light travels through a medium at 1.97 times 10 to the 8th meters per second. What is the index of the medium, and what type of medium is it? Once again, my speed of light in a vacuum is 3.0 times 10 to the 8th meters per second. That is our universal speed limit, according to our friend Mr. Einstein. The speed that the light is traveling in this medium is 1.97 times 10 to the 8th meters per second. And once again, we are trying to find the index of refraction. So I know that the index of refraction is equal to the speed of light in a vacuum divided by the speed of light in the medium, C divided by V. 3.0 times 10 to the 8th meters per second divided by 1.97 times 10 to the 8th meters per second will give me an index of refraction of 1.52. And if we consult our table of indices of refraction, we'll see that the material that has an index of refraction of 1.52 is crown glass. Problem 6. What is the index of refraction of a refractive medium if the angle of incidence in air is 53 degrees and the angle of refraction is 15 degrees? So if we are coming from air into another medium, I know that my index of refraction for air is 1.00. My angle of incidence is 53 degrees, and my angle of refraction is 15 degrees. And we are trying to find the index of refraction for our refractive medium, and that is N2. So once again, we are using Snell's law, and solving for N2 will give me N2 is equal to N1 times sine theta 1 divided by sine theta 2. Plug my known values into that equation, and that will give me an index of refraction for my refractive medium of 3.1. Problem 7. If the angle of incidence of a light traveling through air striking water is 30 degrees, what is the angle of refraction? So we have air striking water. So our incident medium is the air, and the index of refraction for air is 1.00. My refractive medium, water, has an index of refraction of 1.33. My angle of incidence, theta 1, is 30 degrees, and my angle of refraction, theta 2, is what we are trying to solve for. Looking at Snell's law, we are now going to solve for theta 2. Solving Snell's law for theta 2 will give me theta 2 equals the inverse sine of N1 times sine theta 1 divided by N2. Plug our known values into that equation, and we will have an angle of refraction, or theta 2, of 22.1 degrees. Problem 8. If the index of refraction for a certain glass is 1.50, and the angle of refraction is 15 degrees for a ray of light traveling from air. What is the angle of incidence? So it's traveling from air, so I know that N1 will equal 1. My index of refraction for the glass is 1.50, that's N2. My angle of refraction is 15 degrees. So I am looking for my angle of incidence, or theta 1. As always, starting with Snell's law, now solving for theta 1, will give me theta 1 equals sine, the inverse sine of N2 times sine theta 2 divided by N1. Plugging my known values into that equation will give me an angle of incidence of 22.8 degrees. Problem 9. What is the velocity of light in meters per second in a material with an index of 2.0? The speed of light in a vacuum, c, is 3.0 times 10 to the 8th meters per second. The index of refraction for the medium is 2.0, and we want to know how fast the light travels through that medium. The index of refraction equals c divided by v. Solving that equation for v will give me v equals c divided by n. 3.0 times 10 to the 8th meters per second divided by 2.0 will give me a velocity of 1.50 times 10 to the 8th meters per second. Problem 10. A light ray moving through CR39 at an angle of 49 degrees exits into another medium at an angle of 27.48 degrees. What is the index of the second medium, and what is the second medium? My index of refraction for the CR39, which I get from the table on this worksheet, is 1.498. My angle of incidence, theta 1, is 49 degrees. My angle of refraction, theta 2, is 27.48 degrees. And I'm looking for the index of refraction for the refractive medium, or N2. So if we start with Snell's law and solve Snell's law for N2, we will get N2 equals N1 times sine theta 1 divided by theta 2. Plugging in our known values for those variables will give me an index of refraction for the refractive medium of 2.45. And again, if I look at the table of indices of refraction, I will see that the substance that has an index of refraction of 2.45 is a diamond. Problem 11. At what angle is light traveling through each of the mediums below? And we see from the diagram that we have a light that is in air that is incident onto the boundary between air and flint glass. And from flint glass, it goes into water. And then from the water, it goes through a diamond. And from a diamond, it goes through cubic zirconium. And then from that, it goes back into the air. So what we need to do is calculate the index, or the angle of refraction, for each of those mediums. So first, for the flint glass, going from air into flint glass, I know that my index of refraction for air is 1. My index of refraction for the flint glass is 1.61. That's given right on the diagram. My angle of incidence is 20 degrees, which I get from there. And I'm looking for my angle of refraction. So we are starting with Snell's law, solving for theta 2. And that will give me theta 2 equals the inverse sine of n1 times sine theta 1 divided by n2. Plugging my known values into that equation will give me an angle of refraction into the flint glass of 12.3 degrees. Next, we need to calculate the angle of refraction going into the water from the flint glass. So if we look at our diagram, if I draw a normal at the boundary between the glass and the water, I know that it's going to travel, and I'm going to kind of exaggerate the angles here so it's easier to see. But I know that the, oops, stop here we go. I know that my angle or light ray is going to be traveling here. Again, it should be bending a little bit towards the normal, but I'm exaggerating the angle so it's easier to see. And then if I draw another normal right here, I know that this is my angle of incidence going into the flint glass. And this is my angle, I'm sorry, that's my angle of refraction going into the flint glass. This is my angle of incidence going out of the glass into the water. This angle and this angle are going to be the same. They are alternating interior angles. So that my angle of refraction going into the flint glass will equal my angle of incidence leaving the flint glass. So I know that my incident medium, the glass, has an index of refraction of 1.61. My refractive medium, the water, has an index of refraction of 1.33. My angle of incidence is 12.3 degrees, just like it was in the previous part of the problem. And I am looking for theta 2, my angle of refraction. We're going to do the same thing that we did last time, taking Snell's law, solving it for theta 2. And we are going to get our same rearranged equation. And when we do the math out, we will have an angle of refraction into the water of 14.9 degrees. Now to find my angle of refraction going into the diamond. So now we're going from the water into the diamond. My incident medium is the water, and that has an index of refraction of 1.33, so N1 equals 1.33. The diamond, which is N2, has an index of refraction of 2.42. My angle of incidence in going from the water to the diamond is equal to my angle of refraction going from the glass to the water, and that was 14.9 degrees, and we are solving for theta 2, my angle of refraction. We're going to follow the same procedure using Snell's law and solving for theta 2. Do all of the math like we did before, and when we calculate out my angle of refraction into the diamond, I am going to have an angle of 8.12 degrees. Now to find the angle of refraction going into the cubic zirconium. We're almost through this stuff, folks. We're almost there. So now we're going from the diamond into the cubic zirconium. So the diamond is now my incident medium, and my index of refraction for that, N1, is 2.42. The cubic zirconium is my refractive medium, and my index of refraction for that, N2, is 2.17. My angle of incidence going from the diamond to the cubic zirconium is equal to the angle of refraction going from the water to the diamond, and that was 8.12 degrees. We are once again solving for the angle of refraction, theta 2. Going back to our faithful Snell's law, once again solving for theta 2 as we've been doing all along. Putting all of my variables into this equation here will give me an index of refraction of 9.06 into the cubic zirconium. And our final step, we are going from the cubic zirconium back into air. So now the cubic zirconium is my incident medium, and the air is my refractive medium. So my angle of refraction for my incident medium N1 is 2.17. My index of refraction for my refractive medium, the air, is 1.00. My angle of incidence, again, is going to be the same as my angle of refraction going into the cubic zirconium from the diamond. That is 9.06 degrees. And we are looking for the angle of refraction back into the air, or theta 2. Going back to Snell's law, solving for theta 2 once again will give me an index, or an angle of refraction, of 20 degrees. And finally, part B asks, how does the final angle of the light in air compare to the initial angle of the light in the air? So what they are trying to find out is, how does this angle of incidence compare with this angle of refraction? Sorry, I didn't draw my normal very accurately there, but that's what they're looking for in this question. And the angles, if you notice, were the same. This angle was 20 degrees, and this angle was 20 degrees, and that is not an accident. The reason for that is because the boundaries between all of these different medium are parallel, and because they are parallel, it's going to cancel, they are going to cancel each other out. So the light leaving this stack of 4 different mediums is going to be traveling at the same angle as it was when it entered all of those mediums, and that's simply because all of the boundaries are parallel with one another.